1, 2, 3, 4, 6, 7, 8, whatever may be, or symbol. Toss 0 comes mean I will get this amount. 1 comes mean like what are the thing? First player can get either 0 or 1. So what are the m cross n? M cross n in this case. N also will assume that because both are tossing coin. Unbiased. It will not show either 0 or 1. So what are the things? 0, 0, 0, 1, 1, 0, 1. So these are all the only in this case. That means if the first player select f of 0, 0 is some number. So let us say both are getting the same. Okay, the first player will get say 1. F of 1, 1 also 1. Otherwise the second player get 1, let us say, just g of 0, 0, 1, or we'll call it 0, g of 1, 1, 0. Other similarly, let us say other case, 0, 1 goes to say half, 1, 1 goes to, sorry, not 1, 1, 1, 0 goes to half for 1, for f, similarly for g, let us say, then suppose C is selected 0, then which will give the minimum? Yeah, 0, 0, then among that we find the minimum, okay, that. See, what we want is, he has the freedom. The first player has selected only X. He has declared, I have selected S. From words, that strategy set for N may be very large set. He will see, suppose he is having Y1, Y2, Y3, Y4. F is the last function. I mean f of xy, this much loss he is going to get. Then what he will consider f of x comma y1, f of x comma y2, f of x comma y3. Among that which will give the minimum loss. Yeah, loss is minimum. So that way will, okay, you make it more comfortable. I will write, okay, if you want maximum. Similar thing, that's a maximize. If it is maximize mean, who is going to maximize? Then G, X, Y, is now maximize, greater than or equal to G of, he cannot change this. Okay, X, comma, whatever A, for all, for every A in is strategy set N. That is, this is the best thing. Then next question is, this is clear? The first player select X, the second player will select a strategy. If we select Y mean, that Y, that means G of xy will be larger than all other profits. That's why G of xy is greater than or equal to G of A, x comma A. In particular, Y may be equal to A also we are considering. Then what is the next thing we will have to see? First thing what we have to check, what is the right hand side? It is what type of, is it a set? Set of all y in n such that G of xy greater than or equal to G of x comma A for all A belongs to capital N. It is a subset of n. The next what? It is a subset. Empty set also subset. But empty set is subset mean what will happen? I will not get, under any condition I will not get a profit. You want to maximize case mean. So we have to assume suitable condition. Now comes mathematics. So the function is nice continuous function, set is a compact set, continuous function on a compact set attains its maximum or greater, all those things. So that means we will assume under suitable condition for this set is non-empty. Okay, that means this is a subset. This we call it T2 or, okay, I will change the notation if necessary, or we call it T1 of X. This T1 of X is a subset. Under suitable condition we will assume that it is non-empty. We will assume that it is a non-empty subset of N. This clear? Any doubt? So same way now routine. Now the role change. Now what will second player will select a strategy Y and he will inform the player 1, I have selected Y. Now it is your choice. I mean each month or each whatever one occasion I will do, then you have the freedom. Second time you give the freedom to me. That is the understanding. So now second player Y has selected N and Y goes to, now it is the choice of first player. Set of all X from his strategy set M, say that again he want to increase his maximum profit. So F of which is fixed? Y is fixed. Second player has fixed. He cannot change. No, now it may give me loss, I will change the mind. That is no cheating is there. So second player has selected Y. Second player, first player can select anything. Okay. So that if this will give the maximum profit, that means F of X comma Y, what is that? Now profit, we change to maximize. This is to give the maximum profit. Greater than or equal to F of A comma notation, variable, they are also used A, that A variable from N, this variable from M, A comma Y, very good. For all A belongs to M. Again we will assume suitably, this we call it T2 of Y. Again suitable condition we will assume non-empty. Okay, my job is over. If you are able to follow this much, so we are through. It is any doubt, you please go through 1 minute, see that you are able to follow. Not any thing difficult. Any doubt to anyone? First player select X, then second player from where he will have to select? He is going to select from, if we select anyone from the T1 of X. So in a natural way, now define a function T from M cross N to M is a non-empty set of rules or strategy set for player 1, N strategy set for player 2 or set of rules. So M cross N, we know that set of all order for X, Y, so that X belongs to M, Y belongs to N. Now this, which is a subset of M, T1 of X or T2 of Y, which is subset of, pardon, T, first where it is, this T2 of Y. That's why I would have, even if you want, you would have used this is T2 or T1, doesn't matter. Okay. So this is T2 of y, T2 of y here, subset of m. This is subset of m, this is subset of n. So T2 of y cross T1 of, this is T1 of x. This is a subset of m cross n. So that's it mathematically. Suppose m is a subset of R, n is a subset of R, then m cross n is a subset of R cross R. That means m cross n, Ni is compact, m is compact, convex, n compact, convex, then Tikhonov's theorem. Okay, m cross n also compact, convex. compact and also you can prove it convex. Okay, convex is correct. Okay, so we can under suitable for us right now we don't worry about all the things. M subset of R, n subset of R means m cross n subset of R. Suppose m is subset of a non-linear space X, n is subset of a non-linear space X, then what will happen? Shall I erase this? Okay. Suppose M is subset of X, a non-linear space, and a Banach space, Hilbert space, anything you take. Say a non-linear space. N is subset of a non-linear, same non-linear space will take. Then M cross N is subset of X cross X. Can you define a norm on X cross Y? X is non-linear space, Y non-linear space, then X cross Y also a product norm, any one, there are many ways to define. You have seen, third semester MSc students have done functional analysis, they have done or not yet? Oh, at least norm by this time, you know, no, product norm, you are familiar, not yet familiar, mean I will tell. Norm of order, what is the simplest way? X is in X. Then what we know? X is a non-linear space, means for each X in X, we have a length of X. X goes to norm X. Norm X we know. X in X means norm X we know. Y is also in X means norm Y we know. So using norm X and norm Y, again to each, we want to define a X vector space, Y vector space, X cross Y vector space, we will assume over R. Okay. Then in a natural way we can define norm of order per xy. What is the natural way? Even if you are not done, what do we feel? Norm of x plus norm of y, or maximum, or many way, norm of x power p plus norm of y power p whole power 1 by p, 1 less than p, less than infinity, like that. See, we are in a finite dimensional space, means it doesn't matter topologically. Finite dimensional space, all norms are equivalent. Anyhow, what we want is, we have a norm on x cross x also. That means what ultimately we will take is, instead of m cross n, we let k equal to, let k equal to m cross n. Then T is a map from k to k, such that, now what we will tell, we will come back to this situation. K is a subset of m cross n. Then for each x in k, the image is, okay, now suppose some z belongs to k, imply under this condition, T of z is a subset of k. We assume that under suitable condition, T1x, T2y, they are all non-empty. That means the T of Here x means, that z means some order per xy type in our case. That means ultimately what we have, our order per xy goes to t of xy. That is, we call it t2 of x cross t1 of y, anything. So we have here image of each pair xy is a non-empty subset of that m cross n. Non-empty subset. So that map we call it set valued map, or the sometimes also called multivalued map. So that in a natural way, while doing game theory, we come to multivalued map. We get in a natural, we get a multivalued map. That is T from m cross n to m cross n is a set valued, I will write it set valued map. Sometimes they write it instead of m cross n, they write 2 power m cross n. I will assume that set of all non-empty subsets of m cross n. Notation only, so nothing wrong to say that T is a map from m cross n to m cross n, such that for each element order per xy from m cross n, the image is a non-empty subset of m cross n. Non-empty mean, subset mean including singleton. Empty we assume that non-empty, because we want at least the game should not be, empty situation we don't want. Now, what is our aim? What is our aim? You should not forget keeping what was our purpose. Our aim was, forgot, we have two players m and n, set player 1, player 2. M set of rules for player 1, set of rules for player 2. And if the player 1 select a rule from his strategy set or set of from M, second player select Y, then f of xy is the profit for player 1, and the same time, the same situation, g of xy profit need not be same. G of xy profit is, second player profit is g of xy. Then what is our aim? Maximizing whose profit? Player 1, you favor player 1 may be your friend. So I want to favor player 1, so let him, what is the situation here? Whether there exists a situation where both player will get the maximum profit. That is, let us say player 1 selected a strategy x0 and player 2 selected y0, then f of x0 y0 is the maximum, give the maximum profit for player 1, and same time to player 2 also. G of x0 y0 will give the maximum profit for player 2. So then to get x0 y0 naturally from m x0 from m. So now one need. Now you do the work, and I hope you can come across. Now we have seen that we are talking about fixed point theory, at least. So x0 should belongs to where, y0 should belongs to where. See which way we have defined? First we define T1x. T1x we define set of all y from n, say that g of xy gives the maximum profit. Okay, that means what? If the y belongs to where? Y belongs to T1 of x. So if y belongs to T1x means y is here, then that will give the G of x comma a. This will do. But at the same time, if you select anything from this, it will give. But at the same x and y are fixed. Are you called not? Then g of x naught, key has selected y naught, then g of yeah, first player has selected x naught.
Y is fixed.
Y is no, y naught is if is sorry. Yeah. Here it is. I will change the note. Yeah. Suppose we want to select x naught from M, y naught from N. Then this selection should give the maximum profit for both. That means x naught belongs to where, y naught belongs to where. You tell this. Yeah, you can take 1 minute. I mean even 2. Question is clear? If you have understood the definition of how we define T1 of x and T2 of y, proof is over. Anyone? At least this, I want that one of, at least some of you should get. By this time you should have got. See, x naught, y naught belongs to, if we want such a x naught, y naught, belongs to our domain. T of x naught, y naught. What is T of x naught, y naught? By our definition. Very good. T2 of y naught cross T1 of x naught. Very good. Now tell. Image of order pair x naught, y naught equal to T2 of y naught cross T1 of x naught, which is a subset of M cross N. Now can you, if there is a relation between x naught, y naught and this set, that means essentially x naught, y naught is one point, image is another point. When the second player will get the maximum profit? Huh? Very good. Yeah, then what is the meaning of that? Sir has written x naught belongs to T2 of y naught and y naught belongs to T1 of x naught. Very good. So what do you mean by this? See, I will write. See what you check what so he has taken, he is giving the condition not belongs to T2 of y naught and y naught belongs to T1 of x naught. That means what? X naught, y naught belongs to T2 y naught cross T1 of x naught. This is equal to what? T of x naught y naught. See, this is like together some z, this is some z. That means what? Z belongs to T of, suppose order pair x naught y naught, it is an element of a non-linear space or R cross R. That we call it Z. So that means Z belongs to, so we want to suppose that this belongs to T of Z. So what do you mean by Z belongs to? For each element in the domain, the image is a non-empty subset, that is a multivalued map. Then our requirement is, suppose we get an element Z in the domain such that Z belongs to T of Z, then according to him we will verify. Then that Z will give maximum profit for player 1 as well as player 2. That means that Z equal to order pair x naught y naught, such a situation, if such a pair exists, you have to prove under what condition, what is the condition on the domain m cross n, and what is the condition on the payoff function. Then under suitable condition, yes, there exists a point order pair x naught y naught belongs to m cross n, such that order pair x naught y naught belongs to T of x naught y naught, and that gives maximum profit for player 1 as well as player 2, and that pair is called our starting point. That we call it now equilibrium point. That is introduced by Nas, I think either 51 or 52 somewhere, when he was like many of the MSc students' age. He was just 21 or something.
That might be called coincidence point.
No, coincidence point is fixed point in, this is not coincidence point.
Saddle point maybe.
Saddle point is different. It is called, even that's one of the, many books on game, mathematical economics it has, that's what, as I told in the yesterday, Nas using Prover fixed point theorem. What is Prover fixed point theorem? Like M compact convex, N compact convex, M cross N is compact convex. Under suitable condition, F is a continuous, or we can assume lower semi-continuous or upper sufficient. So suitably condition on F, some continuity condition, that will give the map. Even one can use Prover fixed point theorem, that is more easiest is Kakutani. We can give a simple proof using Kakutani theorem, because in a natural way this is multivalued map.
Yes.
So for each X, the image is a multivalued map. What is Kakutani theorem? That was proved by Kakutani 1940 something later in the some Kakutani generalized Prover fixed point theorem to multivalued map, that to finite dimensional. What is that statement is? X is a finite dimensional non-linear space. You have to stress non-linear space or Banach space. Pardon?
When it computes, then we say
A finite dimensional, whether it is?
Finite dimension is always Banach or not.
Okay. So we have a finite dimensional non-linear space. So X is a, I will write this, will retain. X is a, like even R power n you take. Vector space over R power n type. T from x2, that's it, if you want 2 power x we can write, or that for each x, the image Tx, non-empty, closed, convex is more important, convex subset of